Hello everyone, welcome back. This is Ahmed again for Eduonix, and this is beginning DevOps, Section 3, Containerization with Docker or using Docker. And in this lecture, we're going to start by defining Docker networking, or how you can access the Docker container or a network service on the Docker container using different networking methods. A Docker container is not a virtual machine. This means that it uses the existing network interface of the host. Once a container is created, a private loopback interface is available for the container for internal communication. It is totally isolated from the outside traffic. So let's have a look at our example system. And if you have a look at this machine, for example, so let's give it a name of server 1, for example. And a good switch here is --rm. --rm will ensure that the container is going to be deleted once it is finished. Once we finished working with it, once it exits, it's going to be deleted. And that is very handy when you want to use a container just for one task and you don't want it again once this task is finished. So this is our scenario here. We are going to build a container on busybox, and we are going to run ifconfig-a. It's just gonna run this command and it's gonna exit. So let's run it. Okay, I'm sorry, I'm gonna this has been run in the background. This needs to be run in the foreground, so it's -it. And as you can see here, we have two different interfaces that have been created for us once we run the container. EDH0, and this have an IP address already assigned to it, and the loopback interface. This loopback interface is directly connected with an interface that is created on the host machine, which is Docker 0. As we can see here, IP80DR, because this is Ubuntu 7, it uses IP80DR instead of ifconfig. So here we have the normal network adapter for the Ubuntu machine, and we also have a Docker machine, a Docker bridge interface that has been created when we install Docker. This acts as a router between the Docker containers and the outside network, and also between the Docker containers and themselves, and between the Docker containers and the host. Actually, this Docker 0 is responsible for all network communication among the Docker containers that get created on a specific machine. And when it comes to networking, Docker has 3 modes of networking: closed, bridged, and open. Let's have a look at them one by one. So let's clear the screen, and we're going to discuss the closed networking model. Okay. In the closed networking, or in this scenario, the container is totally isolated from any outside networks. It cannot communicate even with the host. You can use this model when you want to seal the container from any traffic, even from the host. The loopback interface is used only for internal communication inside the container. Let's see how we can create a closed container. So it's Docker 1-it, because we're gonna run a command --rm to delete the container once it's done. And now we're gonna use a new switch, which is --net. --net specifies the type of networking that we are going to use. I can specify none. Then busybox, and I'm gonna run ifconfig-a again. Running this command will give me only the loopback interface. Compare this with the output we just received when we ran the ifconfig on a normal busybox container. That is because by default there are 2 network interfaces created for each container, and that is actually called the bridged mode, which is the second mode of networking. So the bridged networking model or mode. This model is the default model, as we have just mentioned. So if you want to use it, and notice here that I did not specify a name, that is because I don't need to work with the container once it is finished running the command. So I don't need to specify a name, and this container will just gonna be deleted once it is done. So if I omitted this --net, I'm gonna have 2 network interfaces, just as we have mentioned before, but I can explicitly specify that I need this to be a bridged interface or a bridged network. That will, I'm sorry, it's bridge. I have an extra D here, it's bridge. Okay, and that will give me the exact same output as when I omitted the --net, because this is, as we said, the default behavior or the default network model when creating new containers. And the final model is called the Open Network model. And this is going to be discussed when we discuss how to access the internal ports of the container, because it is closely related to how you access the ports of the container running on your system. And that will be the starting topic of next lecture, so see you next. Hello everyone, this is Ahmed again for Eduonix, and this is Beginning DevOps Section 3, Containerization with Docker. In the previous lecture, we have discussed the different models of networking in Docker, and we have only discussed 2 of the 3 modes. We discussed the closed network and the bridged network, and we postponed discussing the open network model when we discuss how we can access the internal ports of the container from the host or from the outside network. So if you are having, for example, a web server that is running on your machine, if you have a Docker container that runs a web server, which is the HTTPD or any other web server that you have downloaded and launched, you will need some way of forwarding the port 80, to the host so that you can access your web application or your web server from the host or from the outside world. For this, Docker has 4 different scenarios or 4 different options. The first one is to forward the port to a random port. So let's say, for example, docker run -d -p for port 80. And notice here that I did not specify the port that is going to be forwarded to. --name web server, and it is going to be based on an image that is called HTTPD. We have already discussed this image in a previous lecture of this section, which is an image that contains the Apache 2 web server. So pressing enter, of course HTTPD image is not found on my system, so it has to be downloaded. It's gonna take a few moments, so let's pause the video and return back when it's done. Okay, so now the image has been downloaded and the container has been created. And notice here that if we issue docker ps, you're gonna see that we have the HTTPD running. And if you remember from a previous lecture when we had a look at the Docker file that was used to create this specific image, it had the command that is called httpd-foreground, and as you can see here, okay. And notice here the ports. The ports is forwarding the port 32768 to the port 80. But what is this port? This port is a random port that has been chosen by Docker, and it is forwarding all traffic that is coming at this port on the host machine to port 80 on the web server or on a container that we have just created. In order to see this in action, let's launch the browser of Ubuntu, the browser that is installed on the machine, and let's go to localhost. Of course, if I just type localhost like this, I'll see nothing because no web server is installed on the machine itself. The web server is installed on a container inside that machine, and in order to access it, we need to type in the port 32768, and now we have it works, which is the default page that is served by the Apache web server once it is deployed for the first time. Okay, so that is the first mode of networking, or the first mode of, let's just minimize this so as not to show in the background. Okay, so this is the first mode of port forwarding, which is choosing a random port by Docker and forwarding all the traffic on this port to the port that you need to use. The second scenario, which is the most commonly used one, is to assign a port. You assign a port that will handle this forwarding instead of letting Docker assign this port for you. So let's use docker stop web server and then docker remove web server, because we're gonna create it again with different options. Okay, now I'm gonna run the same command, but this time I'm going to add 8080:80. This means that I need Docker to forward any traffic that is coming at port 8080 to port 80 on the container. If I click enter and I run docker ps again, I'm gonna see that I have forwarding done at port 8080 rather than port 32768. And now if I go to the Firefox browser and I try to refresh this page, I'm gonna see that I'm unable to connect because I have specified a port that is not forwarding traffic to anything or to anybody. I can use 8080 now, And again, I have Eduonix, which is the default page for the Apache web server. Now, both of those scenarios have an extra option that allows this scenario to be bound to only a specific IP address on the host. So the host is having an IP address. Again, I need to use IP80DR. So the host is using the IP address of 10.0.2.15. So I can use this here instead of localhost 10.0.2.15. And if I did that, notice here that I'm accessing the public IP address of the machine. 10.0.2.15 will give me the same output here, the same default page of Apache. Now, let's clear the screen. And again, I need to stop the web server and remove it. And let's say that I want to bound this port to a specific IP address on the host. Let's say that I need it to only run on the local loopback address. I don't need any traffic coming at the host to be forwarded from port 8080 to port 80. I need this action to happen only on localhost. So if I did that, and I go again to Firefox and I refresh the page, I'm gonna see that I am unable to connect. There is nothing listening at port 8080 on that IP address. However, if I change that to be localhost or 127.0.0.1, which is the IP address of localhost, I will access my web server without any problems. This can also be done with the first scenario or the first option, which is to use a random port. Just remove this port from here and you're gonna be left with two columns like this. And now I'll just need to know which address has been which port has been used. So it's 32768 again. So if I use this 32768, I'm gonna have Eduonix. However, if I use that same port with 10.0.2.15, I'm gonna have unable to connect because it is only listening on the local address. And this can be used if you have multiple addresses on your machine. If you have multiple network interfaces or multiple IP addresses, you can control which IP address of those or which interface is going to receive traffic for your machine. So that is how you can access internal ports of the container, or how you can connect to the web services that might be running on the container using the host or using the outside network. That brings us to the third model of networking in Docker. Let's clear the screen, and this is the open model. The open model does not forward any ports. It just makes the container accessible from the host or from the outside network on the port that it has used. So let's stop the web server and again remove it. In order to use the open model, use docker run, for example, -d for detached, -- name web server again. And now I'm gonna use --net, and instead of using the bridge, I will use the host model or the host mode. And of course, this is gonna be based on HTTPD as usual. Now, if I use docker ps, I'm gonna see that I no longer have ports. Why? Because there is nothing that is forwarded. In other words, if I go here to the public interface and I remove the port, I'm gonna be greeted with Eduonix. This is the default page of Apache. But notice here that I'm not adding any ports whatsoever. This is as if the container is running using the host's port, using port 80 on the host, rather than forwarding anything to the container. Actually, forwarding is done behind the scenes, but the point is it is using the same ports as the host. It is actually also using ports that are reserved, ports that are under 1024, which are naturally reserved, and they cannot be used except with elevated privileges. The container is using it. So be cautious when using this model of networking, because this provides the least protection of the container. The container now is accessible from the outside network and from the host on non-privileged ports. And this, of course, poses a security threat, so you must be very cautious when using it. You must install only trusted applications on a container that is used to run in this host or this open networking model. And that brings us to the end of this lecture. In the coming lecture, we're going to start by discussing Docker storage, or how you can access files and share files between the host and Docker. So until then, see you next. Hello everyone, welcome back. This is Ahmed again for Eduonix, and this is Beginning DevOps Section 3, Containerization with Docker. In this lecture, we're going to start by discussing Docker storage, or how you can share files between the host and the Docker container. In order to understand Docker storage, you have to understand how Docker saves files, or how Docker uses file systems to work with files. Docker uses a file system that is called UFS, or Union File System. This basically means that an image may be a combination of a number of images, each of which has its own file systems. Those file systems are layered together so that common files and libraries can be reused. Remember when we discussed how to use a Docker file to build an image, and we said that a Docker file will most of the times or often use a base image that will be the ground for building other images or other functionality. So you use a Debian image, for example, and you install the Apache HTTPD server on top of it, and then you build a new image and call it a web server, for example, or an Apache web server. So in order to save space and in order to boost performance, the file systems from the base image or from the Debian image is shared with the Apache, is shared with the new image. So think of it as a stack of layers that are placed on top of each other, with those layers belonging to different images. And the last image, or the image that the user is working with, is a combination of all those layers. This file system is not suitable for all scenarios. When you want to share files with a Docker container, you'll have to use volumes, or you'll have to use mount points for this. That is because Union file systems are not suitable for every use case. They have their own limitations. For example, SE Linux cannot work with Union file systems. So what is a volume? A volume is just a mount point to a directory that is inside the container where files can be shared with the host. And this is just one type or one scenario of storage, because we're going to have bind mounts, we're going to have named volumes, and we're going to have TMPFS volumes. It works just like /vagrant that we covered earlier in the Vagrant section, but of course in a technically different manner. Actually, Docker supports three methods of storage: volume, bind mounts, and TMPFS mounts, as we have just mentioned. Let's have a look at the difference between each one of them. Okay, let's have a look first at this diagram. This is a Docker container at the middle, and at the right hand side we have the memory, and you can use a TMPFS to store files in memory. We're going to discuss that later. Or you can use the bind mount points, or the bind mounts method to store files directly on the host file system, just like when you use the /vagrant with Vagrant machines. Or you can use the named volumes to store files in a Docker managed area that is also on the host file system, but the difference is that it is managed by Docker. We're gonna see how this works in a few moments. Let's start by bind mounts, because they are the easiest. A bind mount refers to a mount point on the host that targets some destination directory on the container. Let's have an example. We are going to create a web server, just like how we did it in the previous lecture. However, we're going to provide a way for the host to share files with this web server. Let's say, for example, to add HTML files to be served by this web server. So let's have a look at our Ubuntu machine, and we are going to issue first docker stop web server, followed by docker rm web server. Okay, and then we're going to recreate that container, but using a slightly different set of options. So first it's docker-d-name web server, then -b8080 to be forwarded to 80. We're going to use the bridge method. Then we're going to use -v for volumes, and we're going to use a mount, a bind mount. A bind mount takes two paths. The first path is the path to the host file system or directory, which is a mount point, and followed by a colon. Let's say path to host, followed by a colon. Then it's gonna point to path to container. This is the path that the mount point will point to. This is the path where the target files are going to be stored. And of course, we are going to base this on the HTTPD. Just we need to replace those paths to be pointing at real paths. So I'm gonna use a shortcut for accessing the current directory. Just instead of typing /root, which is the path of my current directory, I'm gonna just use this shortcut. This is a bash command that will be translated, or that will be transformed to the path of my current directory when this command runs. And the path inside the container is going to be the path to the location where the web files or the HTML files are served using the Apache web server. On this specific container, they are saved under /user/local/apache2/htdocs, just like that. Okay, and seems that we have a mistake. Okay, we forgot to add run. Okay, and now we have the Docker container up and running. Now let's test our configuration. Let's create a file that is called test.html. Let's add some HTML inside it. Okay, I don't have Vim. Let's use VI. So HTML body. Actually, this is not needed, but just to make it a fully working HTML file, let's type hello world, close the h1 tag, and then finish or close the body and the HTML tags. Now I have an HTML file that is called test.html. Now if I go to the browser and I go to localhost colon 8080, I should see the default page for Apache. But if I specifically navigated to test.html, okay, I don't have permission. Maybe this is a permission problem. And that is because /root, okay, /root is having a restrictive permission. I'm going to share another directory like /opd, for example. Okay, /opd has looser permissions, so I'm going to stop and delete web server. Okay, I'm gonna just move the test.html from my /root to /opd. Then I'm gonna run the same docker command again. And as you can see here, because I use this shortcut, I don't have to re-specify the current directory because it's gonna be already evaluated when the command runs. So I'm just gonna run the command again as it is. And now if I go here and I refresh the page, okay, I have hello world, and this means that test.html has been successfully seen by the container and has been successfully seen by the web server. So that is the first type of mount points. The second type of mount points, or the second type of storage in Docker, is called named volumes. We're going to discuss it in the next lecture, so see you next. Hello everyone, welcome back. This is Ahmed for Eduonix, and this is Beginning DevOps, Section 3, Containerization with Docker or using Docker. This is how Docker uses storage, or how Docker stores files, and how files can be shared between the container and the host. In the previous lecture, we have seen how we can use bind mounts to create a mount point or share a mount point that is pointing to a directory inside the Docker container, and we can place files inside this mount point, and those files will be automatically seen and used by the container. However, this is not the only way you can share files and directories with the container. A Docker named volume is a more recommended way of sharing files between the container and the host. It is a little more complex in setup than bind mounts. However, it is more robust, and as we have said, it is recommended to be used to save persistent data. To use a Docker volume with a container, you can create one first, but this is not the only option. You can actually have Docker create that automatically for you. But let's use the long way first to demonstrate what a named volume is. Let's have a look at our example system, our Ubuntu system. Okay, and let's clear the screen, and let's stop the web server and delete it. We're gonna create it again anyway. And now we need to use a named volume with this web server. So I'm gonna use Docker volume create, and I'm gonna call it web data-vol. Once I press enter, I have a volume created for me. if I want to use this volume, I need first to know where this volume exists on my host. For that, I will run docker volume inspect and give it the name of the volume that I have just created, web data-vol. And as you can see here, I have a set of JSON data, and the mount point, as you can see here, is at /var/lib/docker/volumes/web-data. Let's have a look at this quickly. Volumes, web data, and underscore data. And of course, this directory is totally empty. We are going to use this directory to mount the web data, the web directory of the Apache, the directory that is used to serve HTML files. We are going to mount it to this named volume. So in order to do this, I'm going to issue the same command that I used to create the web server. However, instead of using this this shortcut for referencing the current working directory, I'm going to delete that, and I'm going to use the name of the volume, web-data-vol. Okay. Now, if I ls, I'm going to find that a file has been automatically added for me. A file that is called index.html. If I cat it, I'm going to find that it has the default message that appears when I browse to the URL of the web server. When I browse to localhost on Firefox, it gives me it works. And this is the HTML of the phrase. It works. It's just a heading H1. This is the file that is responsible for displaying this phrase. So if I added here a file, let's have the file that we have just created from OPT. Let's just put it here. And if I go to the web browser and I refresh the page, I'm gonna see that the file is displaying correctly. So this means that I am using a named volume to share files between the container and the host. And actually, I could have skipped this step of creating the volume. If I just use this command and the volume was not created, it's gonna be created automatically for me. And then I can use docker volume inspect and give it the name of the volume to know where Docker placed the files. So why use volumes over bind mounts, and what are the differences? Actually, there are a few differences between both types of file sharing or data sharing, but the most important reason is that a named volume makes the container portable, as it is not dependent on the host OS. Remember, when you use the bind mount, we specified the mount point on the host operating system. This means that this mount point has to be created, has to be present on the host operating system before we can use the container to access files on it. This is different from the Docker named volume because the Docker named volume is managed by Docker. Docker creates that named volume for you. Docker creates that volume for you and handles all the sharing between the container and the host. So this makes the container portable because you cannot refer to a bind mount inside a Docker file. Remember when we discussed the Docker file at the start of this section, and we said that the Docker file is used to build images based on other images, and you specify different instructions inside this Docker file to instruct Docker how the image should look like and how it should behave. So if you want to refer to a mount point or a location where files are going to be shared between the host and the container, you cannot reference a bind mount for obvious reasons, because the bind mount is dependent on the OS. I have used, for example, /opt as my mount point. On another system, maybe I want to use /opt/data or /temp/www, for example, or any other mount point. So this is dependent on the host OS. On the Docker named volume, I just give it the name of the volume, and Docker handles the rest. Docker handles the physical location of this named volume on the system. As you can see here, it is creating this directory for me, it is managing this directory for me, and I can refer to this named volume inside my Docker file when building new images, so this makes my containers portable between different operating systems. Now let's have a look at the final type of Docker storage, which is called the TMPFS mounts. The TMPFS type of mount is used in scenarios where data does not need to be persisted on the host machine. This means that whenever you stop the container, whenever you finish working with the container and it is stopped or restarted, the data is gone. An example of this scenario is when you need to generate a password or a hash or a piece of sensitive information or a piece of sensitive data that will be used in the current session and in the current session only. it does not and should not be available once the session is over. If you use a TMPFS mount point with a container, any data written to this location is going to be stored in the host's memory rather than the file system. Once the container is stopped, this data is gone. And as a matter of fact, this type of mounting, this feature does not work on Windows machines. It only works on Linux or Mac OS machines. So let's see how we can use this. So again, this time we don't need to have a web server. Let's just create a BusyBox machine. So docker run -itd name, let's say secure server, and in order to use the TMPFS mouse, I'm gonna specify --TMPFS followed by the directory or a file system that is gonna be used to store this data using the TMPFS. And of course, this is gonna be based on BusyBox. Okay. Now just make sure that it's running. Okay, it is running. And let's use docker attach to access this server, to access this container. So docker attach secure server. This will give me an immediate access to the shell of this container. And now I can go to /temp, which is the TMPFS. Anything that I write to this /temp directory is going to be saved in the memory of the host system rather than on the disk. So let's create a file. Let's call it secure, or let's call it, let's say, password. Anything that is supposed to be sensitive, or anything that you don't need to be persisted across reboots. Let's write this is a sensitive piece of information. Okay. Notice here that I have a passwords.txt file and it has this text. This is a sensitive piece of information. Now remember when we mentioned that if you are in a BusyBox, that if you are in a container that is running the sh command as its foreground command, and you typed exit, the container will be stopped and it's gonna exit, because this is the only process that's running. If you exit the process finishes or it just drops. So if you're on docker ps, you're gonna find that the secure server is no longer running. If you want to run it again, just type docker start secure server, the name of the container. Now if I go to secure server again, if I attach secure server and I go to /temp, I'm gonna find that it's totally empty. There is nothing inside this /temp. And in order to demonstrate this further, let's clear the screen and let's remove secure server again, and let's remove secure server because when I create it again, but this time we are going to omit this part. /temp is no longer going to be a TMPFS. Now if I run docker attach secure server and again I go to temp and I touch a file, don't have to write anything inside the file, just touch password.txt just to ensure that it is there. Okay, it is there. I'm gonna press Ctrl D to exit from the shell, and of course that means that the secure server now is no longer running. If I start it again, okay, and I attach so that I can access the shell again, and I go to /temp, I'm gonna find that password is there because password.txt has been saved to the file system, has been saved to the disk of the host operating system rather than to memory. That means that whenever you restart the container, whenever you stop it and start it again, you will find that the file is in place. It has not been deleted, and that is because it is using persistent storage. But when you use the TMPFS, it vanished when you stop the container, or if you restart the container, it's not gonna be there. That is because it is saved to memory, and it is saved for the current session only. Now, I guess by now you have a better idea about how Docker manages storage and how Docker can share files between the container and the host machine. In the coming lecture, we are going to create a lab where we are going to apply all what we have learned so far in the Docker section. We are going to create a LAMP stack, and we're going to also deploy the WordPress famous CMS on top of that LAMP stack. We're going to have two containers, one for the database and one for the application. So until then, see you next. Hello everyone, welcome back. This is a new lecture in your course, Beginning DevOps by Eduonix. My name is Ahmed, and this is the third section of this class titled Containerization with Docker. In this lecture, we are going to start our lab, in which we are going to apply what we have learned so far in the Docker section. We are going to create a LAMP stack, deploy WordPress CMS on top of it. We are going to use two containers, one for the database, and the database is going to be MariaDB, which is a forked version of MySQL. And the other container is going to be used for WordPress. It's going to have the web server HTTPD. On top of it, we're going to have PHP. On top of that, we're going to have WordPress installation. If you want to install a container, it is a very good idea to have a look at its page on the repository, on the Docker Hub, because this will give you a better idea about the options that this container can accept and how to use it in the first place. So this is giving you just an introduction to MariaDB, what it is. We have just mentioned that it is a forked version of a MySQL. Okay, and this is how you can use the MySQL, different options like the CNF file. These are the environment variables, and environment variables are an excellent way to inject configuration to a container without having to log in to that container and changing the configuration files yourself. So in our case, we can specify the database root password, the name of the database that is going to be created, a user, a password to that user, allow empty passwords, other options that is used by MySQL. Okay, so again, it's a good idea to have a look at this page whenever you want to install a Docker container, because it gives you information about how to use the container and how to get the best out of it. Okay, let's get back to our Ubuntu machine, and I'm gonna use Docker run. I'm gonna create a container that has MariaDB installed, and since there is already an image that has MariaDB, I'm gonna use that image instead of having a blank image and manually installing MariaDB or MySQL. So Docker run -e, and -e is the switch that is used, or the option that is used to inject environment variables. Environment variables, as we have just mentioned, are a way to change the configuration of the container without having to log in and change that configuration by editing files. So MySQL root password is the first thing, setting that needs to be configured. I'm going to use admin, which is a very weak password, but it's just for demonstration purposes. Then I'm going to have a MySQL user. Let's call it WordPress. This is the user that will be used to connect to MySQL once it is created. Another environment variable is the password, and this password is used for the user that we have just created or that we have just set, which is WordPress. I'm gonna give it a password of WordPress. Then the name of the database, MySQL database, I'm gonna call it WP_database, which is the database that WordPress is gonna use for its installation. And those are the options that I need for configuring MySQL. The next thing I need to do is defining a volume from which I can have backup of this database. I need to have access to the data files that MySQL uses to store data. This needs to be accessible from the host as well as from the container. So I'm going to use a volume, a named volume. I'm going to call it WP_database, and this is going to point to /var/lib/MySQL, which is the default location where MySQL saves the data files. And as we have just mentioned in a previous lecture, if you did not create a volume previously before running this Docker run command, Docker is going to create this volume for you if you're using a named volume. But if you're using a mount point or a bind mount, you will have to create a mount point prior to running Docker run for obvious reasons. Now, we're going to give it a name. The name is going to be WordPress DB for WordPress database. And of course, it's going to be based on the MariaDB image, which is not installed currently on my system. So Docker is going to fetch it from the repository. It's gonna take a few moments to finish, so I'm gonna pause the video until it finishes and then return back to you. Okay, so now the MariaDB container has been downloaded as an image, and the container also has been launched. If you run docker ps, you're gonna see that we have WordPress DB up and running. Now I need to ensure that the database has been created as requested and that it is ready for a WordPress installation. So in order to do that, I need to connect that database using a MySQL client, and I don't have this installed, so I'm gonna have to install it. Sudo apt-get install MySQL-client. Okay, and actually you can use any client you have to connect to MySQL. I personally prefer the command line MySQL client, but you can use whatever client you prefer for connecting to MySQL. Okay, once it's installed, let's clear the screen and use MySQL-u, which user is WordPress, P is WordPress. You can type the password at the command line, which is of course an unsecure practice, and it is highly not recommended if you are running a production system. Never write the password like this on the command line, just using it here to save time. But now I need -h, I need the IP address of the container in order to be able to connect to the database, and I don't have this IP address, so I'm gonna cancel this command and I'm gonna use docker inspect followed by the name of the container, which is WordPress DB. Press enter. It's gonna give me a lot of information about the different settings of the container, including the network settings, and I have here the IP address. It is here, and if you want to just get the IP address, you can just grab -i IP address, and it's gonna only give you the IP address. Only the IP address part of the output will be grabbed for you just using grep. So it's 172.17.0.3, so I'm going to use MySQL-u WordPress-p WordPress-h 172.17.0, sorry, .0.3, pressing enter. I am inside MySQL. Let's see if the database is created. So it's called wp_database, if I remember correctly. Okay, and database changed. This means that I do have a MySQL installation, and it is ready for running the WordPress installation. It has the username, it has the password, and it has the database. Let's exit. And now let's clear the screen and start with installing the WordPress container, the application container that is going to bundle the web server, the PHP libraries, and also WordPress application. So it's docker run -e for environment variables again, and we are going to use the following environment variables: WordPress _db _user is WordPress. And if you want to have a look at where those environment variables came from or how to use them, just head to the Docker Hub, search for WordPress, which is the name of the container or the image. Okay, and as you can see here, visiting the page of the image, you're gonna see that you have here the manual or the help for using this image, and these are the environment variables that you can use. As you can see here, I'm using some of those environment variables, not all of them, for the sake of simplicity, but I'm using the enough variables to get my WordPress installation up and running. So let's return back to the Ubuntu system just to show you. I just wanted to show you where those environment variables came from. These are just dependent on each image. Each image has its own set of environment variables. So WordPress DB user is WordPress _db _ password is WordPress. We already did that. -e WordPress _db _ name is wp_database, and finally WordPress _db _ host will be the IP address of the database host, which is 172.17.0.3. Then we just need to forward port 8080 to port 80 in order to be able to access our WordPress installation from the browser using port 8080. And then I'm gonna create another named volume called wp_data that will be mapped to /var/www/html, which is the default path where WordPress files are gonna be placed, --name, where the name of the container, I'm gonna call it WordPress app -d. Of course, this is gonna be based on WordPress. And clicking and pressing enter is gonna again find the WordPress image. It's gonna download it. Again, it's gonna take a few moments to download. I'm gonna pause the video and return back once it is finished. Okay, the Docker image has been downloaded and the container tried to launch, but it failed because we have a port conflict. That is because we are already using the port 8080 for the web server, so we either change the port or use a different one. I'm going just to stop web server, don't need it anymore, and I'm gonna delete it. Perhaps I will have to delete this WordPress app container, recreate it again in order to work. And now it is up and running. If I run docker ps, I'm gonna find that I have WordPress DB and WordPress app running. Now let's clear the screen and let's have a look at the WP data volume. Okay, it's at /var lib docker volumes WP data _/data. If I ls, I'm gonna find that I have all the WordPress files here. If you're familiar with WordPress, you sure have seen those files before, the configuration files, the WP-content, which contains any uploaded images and media that you upload to your WordPress installation and so on. So this is a perfect way to have backup of your systems and also to share files between the container and the host, as we have already mentioned before. Now let's go back to our browser, and we are going to use the same 8080 port just to remove this test.html. And now we're gonna see that, okay, this is the cached version of the page. Let's refresh, and now we are at the installation page of WordPress. It's gonna appear in a moment. Okay, now I'm gonna use English, beginning DevOps as the name of our website or application. Username is admin. Let's have a copy of this password and let's install WordPress. Okay, it needs a name. Okay, let's press install, and as you can see here, it has successfully installed WordPress. This means that the connection between the application and the database is successful. Both of them are working on the Docker bridge interface that we have discussed, and both of them are connecting with the host via port forwarding. As you can see here, I have a successful installation of WordPress, and congratulations, you have just used Docker for installing the LAMP stack, and on top of it we have a WordPress installation. So before finishing this section, a question might pop up in your head, which is whether to use Vagrant or Docker when you want to provision a software or an application, or if you want to build your infrastructure. Actually, asking a question like that is just like asking whether to drive your car to work or take the bus. This highly depends on your use case and scenario. What are you going to use your infrastructure for? Vagrant is a virtualization software that works on top of a platform like VirtualBox or VMware. Using Vagrant, you have a complete virtual machine with its own CPU, memory, and network stack. Virtualization tends to consume a lot of resources since everything needs to be abstracted. All the hardware needs to be abstracted, and the hypervisor eats a lot of resources in order to do that for you. However, it can be used, for example, in cloud platforms, for example, for instant provisioning. If you want a machine that will be under your disposal that you will use to install multiple applications and you're going to play with the network, you're going to do some sophisticated stuff, you're going to install several software stacks and try different things on the same machine, so you better off use a Vagrant machine or a virtual machine. Docker, on the other hand, as we mentioned before, uses containerization, which means that the image will create containers that share the same Linux kernel of the host with the appropriate level of isolation. This means a lot less resources overhead, but at the end, it is just a Linux process running an application, not a complete machine. If you remember, throughout this section, we have seen that the container at the end of the day is just a process running some command. If this command exits, the process terminates and the container is stopped. So to answer the question, actually they both complement each other, with Vagrant abstracting the machine and Docker abstracting the application. For that reason, Vagrant uses Docker as one of its provisioners. This means that you can deploy a Vagrant machine that will automatically deploy a Docker container once it boots. And that brings us to the end of this lecture and to the end of this section in Beginning DevOps by Eduonix. This section was titled Containerization Using Docker. I hope you have now a firm understanding of Docker as a DevOps tool for provisioning and infrastructure. My name is Ahmed. I hope you enjoyed this section and see you next.